Okay, so once again, I'm going to go over these problems, and I'm just using an answer key that I already have filled in. Instead of printing out a blank one, I do have a lot written, so I am going to try and explain my answers as well. I just have this covered up because there's a lot written there that would just be distracting. So, first problem here, you have an irregular figure, right? Because like this doesn't have a name. So I split it up into two rectangles and a triangle. This is not the only way you can do this problem. So if you're like, oh, I was thinking more like this rectangle or this rectangle, yeah, great, that's fine. You should get the same answer at the end if you're doing the correct algebra and math, of course. But the three shapes I have, this rectangle here, the dimensions are 4 and 7, so that's 28. The area is 28. For this rectangle here, I have to add the 6 feet and the 4 feet to get 10 feet as my dimension, and then this length here is 11 minus 7, so it'd be 4. So the area of this rectangle is 40. And then the triangle, the height of the triangle is 11. This length here is just 3, because this whole thing is 13, this is 6, this is 4, so leaves me with 3. So half of 11 times 3 is 16 and a half. So when you add those three together, you should get 84 and a half feet squared. Okay. Now, if we were doing this in class, like, I don't know, I'd just make it way more exciting than just a worksheet, right? I would have different shapes drawn on the chalkboard. I would have one taped up on the window or the floor, just to, help you, like, or enable you to move around, and maybe, with chalk you can kind of draw stuff in and erase it a little bit easier. But alas, we are on Schoology and everything has to be online, so a worksheet it is. Okay. Now this next problem is a little bit trickier because you have to watch your units. So they give you the dimensions of a playground. They tell you how much sod costs, which is like just ground. So $1.69 per roll, and they give you the dimensions of the sod. So you have to figure out how many rolls you need to buy to cover the playground. So basically, you need to find the area of the playground and the area of the sod, which both of these are rectangles, so it's just, length times width. But you have to put them in the same units. So you can put them both into yards, convert them both to yards, and then, do your work, or convert them both to inches. I worked in inches because then I didn't have to worry about fractions and decimals. So there are 36 inches in a yard. So you need to take 60 times 36, and you need to take 120 times 36. And that's these numbers here, I believe. So when I multiply them together, I get this large number, which is the area of the playground. Then when I multiply 24 times 72, I get 1,728, which is the area of the sod, the roll of sod. So once you have those two areas, you just have to divide them to figure out how many rolls you need, which is 5,400. And then I multiply that by the price to get my $9,126, which is the final answer. Okay, but even if you converted them both to yards, you would get the final answer in the end. So just watch your conversions. It's 36 inches in a yard. So if I converted these to yards, I would do 24 divided by 36 and 72 divided by 36, and that will give you how many yards that is. So there you go. A little bit of algebra and geometry together. Next problem here. Again, you just have to split it up into whatever shapes you like to work with. So I went with a rectangle, and this is a trapezoid. So the area of this rectangle is just 27. The area of the trapezoid, I have it written here, half of the height, which is 9, times base 1 plus base 2, right here. So that's 40 and a half. So then once you have your two numbers, just add them together. Again, if you split it up into different shapes, it doesn't matter. You should get the same answer at the end. Okay. For number 4, it says, what is the area of the shaded region in the figure if the area of the rectangle is 44 meters? Okay, I believe the problem you're working on still has 44. I should check this out before I made the video. But but this is the shaded region, so you have to find the area, well, it gives you the area of the rectangle, which is 44. I'm going to erase this. So when you do 44 divided by 4, you get 11. Okay, and then once you have that dimension, you can find the area of this trapezoid here. So I'm going to write this over here. So if it's 88 on your worksheet, then you can follow this work, and if it's not, I'm going to write it over here. So the area of this trapezoid is half. The height is 4 times 11 plus 3 is 2 times 14, which is 28 meters squared. So I want the area of the shaded region, so then you have to take your 44 minus 28 to get what's left, and that's 16. So that will be your final answer. I think I changed that because I put the problem on the chalkboard and it just, for some reason, made more sense. Oh, there you go. Okay, so for number 5. Now, on mine and maybe on yours, like, it's hard to see the lines here. This is just on the coordinate plane. So to find the area of the triangle, you just have to count the blocks here to find the base and find the height. So 13 and 9, half of 13 times 9 is 58 and a half. That's a pretty easy problem. Okay, and the last 2 here, almost more of like an algebra problem than geometry. But it says a basketball court has a perimeter of 232 feet. The length of the court is 32 feet greater than the width. What's the width of the basketball court? So pretty much we have a system of 2 equations. The perimeter of a rectangle is 2 of the lengths and 2 of the widths, and that equals 232. And then we know the length is 32 feet greater than the width. So you could probably use guess and check for this. I'm sure this is not the only way to do this, but of course, as a math teacher, I just think equations, equations. So, since this is what the length equals, I just took this, I used good old substitution, I plugged it in for the length, so instead of L, I used parentheses and put in 32 plus W, and then I just worked it out there. So if you want to pause the video and just check out my work, or, try it on your own and then check your answer, feel free, but that's how I did it. So 42 feet is the width. And then the last problem, when we do this in class, and it's usually one of the stations, kids can sit here for a really long time. It's saying he's making a rectangular garden. He has 84 feet of fencing, and he wants to know what length and width will maximize the area of the garden if his perimeter is 84 feet, right? It has to be 84 because that's all the fencing he has. So you have to know, if you want to maximize the area of something, you want the same numbers if possible. So pretty much he's going to make this a square garden, which a square is a rectangle, so it still fits the stipulations. But if all 4 sides are 21, that's going to maximize the amount of area that he can have with his garden. So usually kids are just like guessing and checking for so long. But really the trick here is you just want to make it a square and make both sides the same. Okay, hope that made sense. Thanks for watching.